In this sixth lesson of the Basic Algebra in Full series, you are going to learn about brackets, which is a very useful tool not just in algebra but in mathematics generally. We are going to look at this from basic all the way to advanced levels. So if you are struggling with brackets and you really want to understand it, let's begin. Look at this expression on your screen. You see this set of brackets here, housing 3 times 4. What it just means is that what is inside the brackets is a group or a unit or a mini expression within the general expression here. And it is trying to tell you that you must sort out what is in this bracket first and then put it back in the expression and then simplify the expression. This is exactly what brackets are for. So if you wanted to simplify this further, we will say 5 plus 3 times 4, 12, then minus 2. Once we've done that, we can now remove the brackets and say 5 plus 12 minus 2, which gives us 5 plus 12, 17. 17 minus 2 is 15. Now, before we continue, it is very important for you to note that the things you've learnt in mathematics always remain. Never throw them away. That's why this channel exists, to show you the connection in mathematics. Now, think of brackets as a very large or giant term that also has its own operator. So this operator here, plus, belongs to the everything inside the brackets. So this means that whatever is in the brackets, whatever it is after simplifying, when it comes out, will bear this plus as its operator. What we are saying in essence is that brackets are in an expression does not mean that mathematical laws will change. Now let us go to creating or inserting our own brackets in an equation or an expression that didn't have brackets in the first place. Now look at this expression on your screen. So far we've learned that once we see this, the next thing to do is to collect like terms. So this gives us 2x plus 5x plus 3y plus 6y. We go ahead and solve by adding the like terms. Now at this point I could also insert brackets here and here. Why? Because I know that these are the terms I'm adding, these two and these two. So what have I used brackets to do in this situation? I've used brackets to identify groups based on what I want to solve next. So what does this tell you? It tells you that anytime I'm inserting brackets or anytime you want to insert brackets, don't insert brackets into mathematical situations that are incorrect. So your brackets must follow mathematical situations that are correct. So if we wanted to solve this, we are going to solve it this way: 7x plus 9y. Now even if the brackets were not there, we still get exactly the same answer, still 7x plus 9y. So the brackets just make it easier on the eyes to see or to group. Now before we move on, let us take time and talk about some of the things we've learned so far and how inserting brackets should not stop us from obeying those rules. Now look at this expression on your screen. Now if we collect like terms, this gives us 2x plus 5x minus 6y plus 3y. Now we could go ahead and simplify by adding and subtracting. But if we wanted to insert brackets, how do we insert the brackets correctly? Now, first of all, we put here 2x plus 5x. This is correct. If you go ahead and put the brackets here, 6y plus 3y, you would be wrong because you've left out the minus operator that belongs to this 6y and put it outside the brackets. Once you do this, you've created a totally different expression entirely, and we'll find out the reason why soon. But now you understand what I mean by your rules that you've learned, the things you've learned in mathematics that are always connected should not be abandoned. So the correct way to insert brackets here would be here 2x plus 5x and then here minus 6y plus 3y, because we need to factor in that minus operator. But this is not the correct way either, because brackets have an invisible multiplication sign on their outside curve here. So if you write the expression this way, it's a totally different expression from what we initially had here. Because what you are telling anybody that sees this expression is that 2x plus 5x is multiplying minus 6y plus 3y. So how do you stop this from passing the wrong message or from writing the wrong expression? You need to put a plus sign here to show that this is actually plus. Now, some people may be getting confused here. Why can we put plus but we cannot put multiplication? Because since this series started, we've made it clear when we talked about the operator ownership rule that every term that doesn't have an operator, the default operator is the plus operator. So that means there is a plus here. And of course, when we started this lesson, we said that brackets are like giant terms themselves. So if brackets are like giant terms, then there is a plus here that belongs to this particular giant term. And there is another plus here as well that belongs to this particular giant term, except there is another operator there that is visible. If there is no operator there, then the operator is plus. Let us solve this completely to make it just for completeness. So this gives us 2x plus 5x is 7x, then plus, in this bracket, minus 6y plus 3y gives us minus 3y. This now gives us 7x minus 3y. Now, if you had put the brackets here before the minus of the 6y, you will get 6y plus 3y, which is 9y, which is a totally different answer from this, and it will be wrong. So you see the reason why you need to understand brackets and master them. They are very, very important. Anything you want to do, any level, whether basic or advanced, you need brackets at one point or the other. Another thing we need to mention that is very important to consider before inserting or creating your own brackets is operator siblingship or operator families. Now look at this expression on your screen. We are going to use this to show the importance of operator siblingship or operator families in inserting brackets. As you can see, the operators are from different families, and in such a situation, you cannot collect like terms. You would need the order of operations, as we've been saying since this series started. So the order of operations tells you which particular terms are you going to simplify first and which ones will come next. And once we do the order of operations in a few lessons time, then you can tell us, you can be able to say these ones will be simplified first and these ones will come next. But just for the sake of completion in this particular lesson, the order of operation tells us that this one will have to be simplified first before we now integrate it back into the expression. So this is just to show you that everything you know in mathematics, you still need to know them before you insert brackets. Otherwise, you insert brackets wrongly and get the wrong answer. Now, the last thing we are going to look at in creating or inserting your own brackets is word problems, because it's actually in word problems that you create brackets and also create an equation or an expression. So let's look at this little word problem just for the sake of this lesson. Word problem still has its own lesson. We are just using this to explain brackets. Now this question says add 2 to a number and then multiply by 3. We did this sort of thing in lesson 1. So add 2 to a number. What is that number? We don't know. So first of all, we will add 2 to, let's call the number A. So add 2 to a number. We've added 2 to the number, 2 plus A. Then multiply by 3. If we do this, it will be wrong because 2 plus A times 3 doesn't tell us where to start from. And if we apply BODMAS, then it will make us add the brackets here, which is not what the question is saying. The question says add 2 to the number first, then multiply by 3, which means the correct thing the question is asking us to do is 2 plus A. After that, then we will now multiply by 3. So you see how we've used brackets to show that this word problem is actually telling us to do this and not telling us to follow order of operations if we did not put that brackets. So you see the importance of brackets everywhere you go in mathematics, even in word problems. So this is the whole idea of brackets. So now we will move to removing brackets. There is no way you can get an answer with your brackets still there. In as much as you can create brackets to make your simplification easier and to make your word problems make sense, you also have to remove those brackets to get a final answer. So now let us go to removing brackets in different situations. The first and most important thing we need to learn before talking about removing brackets is what we call the distributive law. And what does the distributive law say? It says that if we had A bracket open B plus C, for instance, to remove this bracket or to expand the brackets, you multiply what is outside with each of the terms one by one. So you multiply A with B first, it gives you AB. Then you multiply A with C, and then it gives you plus AC. So this is what the distributive law is saying. Take what is outside the bracket that is multiplying the bracket and multiply all the terms in the bracket one by one. So that is the distributive law. Let's take an example of the distributive law. Then we look at all the scenarios of how to remove brackets. So look at this first example. 2 brackets open, x plus 3 brackets close. Now, based on the distributive law, we are going to multiply 2 and x first. Then we multiply 2 and plus 3 next. So this gives us 2 and x gives us 2x. Then 2 times plus 3 gives us plus 6. So this will be the answer. So the distributive law is very, very easy. Let's take another example. Now look at this example. Again, we use the distributive law. So 5 multiplies the first term, which is 2x, to give us 10x. Then 5 multiplies the second term, which is minus 3. Remember, I'm always taking the operator. I'm not leaving it out. This is one mistake students make. So you always take the operator. Don't abandon the operator. So 5 times minus 3 gives us minus 15. And that will be the answer. So let's take another example. Now this is x bracket open 2x plus 3. So using the distributive law, x will multiply 2x to give us 2x squared. And then x will multiply plus 3 to give us plus 3x. That will be the answer. Let's take one more example. Now for this one, again the distributive law, minus 2 multiplies x to give us minus 2x. And then minus 2 will multiply plus 7 to give us minus 14. And that will be the answer. Now, just to give you a thorough idea and to prepare you for different situations, we are going to look at how to remove brackets in so many other scenarios that people may find confusing. So we'll take it one after the other. The first one will be how to remove brackets when you have only a plus sign to its left. So here is an example of such a scenario we are talking about. 2 plus bracket open x plus 3 bracket close. So in this situation, we know that there is a 1 here. 2 plus 1 into x plus 3 because there is really nothing beside that bracket except the plus. So you can just open the brackets without doing anything special. Just 2 plus x plus 3. Another way you can look at it is that the plus is the operator of the bracket. So you can just open the bracket. There's no big deal, nothing more to do here. You can simplify this further to give us x plus 5. And that will be the answer. Now, what if we had a minus instead of a plus to the left of the bracket? So that's the second scenario we will look at now. Now, this is an example of what we are saying when there's a minus beside the bracket instead of plus. Now, the best way to view this thing is that there is a 1 here. So, what is happening here is that minus 1 is now the multiplier. What is multiplying everything inside the bracket? So, minus 1 will multiply this. We multiply this. We multiply this with the operators, of course. So, minus 1 times y squared gives us minus y squared. Minus 1 times plus 2y gives us minus 2y. And then minus 1 times minus 8 gives us plus 8. So what basically happened here is that all the terms were just rewritten, but the operators changed to the sibling. You see, plus here became minus, plus here became minus, and minus here became plus. And this is the reason why most students memorize and say when you have a minus sign outside the bracket, just open the brackets and change the operators to their sibling. This is not a good way to memorize. Rather, do it the way I did it. Open the bracket by multiplying it following the distributive law. If you memorize by changing signs, you may make mistake and think or forget that it is when the minus is outside the bracket. For instance, we've seen students, if you had 4y bracket open 3y minus 5. Now, a student who has memorized that when there's a minus with a bracket, I change the sign. The student may forget that the minus we are talking about is outside the bracket and then decide to say that because there is a minus here and there is a bracket, then this now becomes 12y squared plus 20y. That is using the distributive law, multiplying this and then multiplying this. And this is wrong just because they memorized minus and bracket. So always try to understand and memorize less. So the distributive law is your go-to anytime you want to expand a bracket or open a bracket or remove a bracket. So just multiply it as we've explained. Let's look at another example of this particular one because it could be confusing to some students. Now, in this example, you see that 7x is not multiplying the bracket. So people who will multiply this will have made a mistake because it is wrong. 7x is not multiplying the bracket. What is multiplying the bracket is actually minus or minus 1. So pay careful attention to such situations. So if you wanted to solve this, it will be 7x, then the minus 1 here multiplies everything in the bracket one by one. So that gives us minus 3x minus 1 times minus 5y gives us plus 5y. Then minus 1 times plus 2 gives us minus 2. Then if we simplify further, of course, like term, 7x minus 3x gives us 4x plus 5y minus 2. And that will be the final answer. Now, what of this situation where we have a multiplication sign to the left of the bracket? In this situation, you just rewrite the whole thing and remove the multiplication sign. 3a plus 2. Why? Because we already said there's an invisible multiplication sign on the outer curve of this bracket. So putting this multiplication here with this one makes no difference. So you just remove it and you have 5a into the bracket of 3a plus 2. So you can expand it as usual using the distributive law. This multiplying this and this multiplying this. So that will give you 15a squared plus 10a. And that will be the final answer for this. What if it was a division sign? So if we had 5a divided by 3a plus 2 in a bracket, this is basically the same thing we did in multiplication, just that this is now division. Remember that multiplication and division are in the same family. So this is the same thing as 5a over 3a plus 2. So this bracket housing the 3a plus 2 is telling us that this division belongs to all of them. So that's why we can move all of them below as the denominator. So this is the answer here. Now, what of a situation where a bracket is multiplying a bracket? Like when we were showing the first example and we said bracket multiplying bracket like this, x plus 3 times x plus 3 is different from x plus 3 plus x plus 3 when we were explaining that first one, if you remember. So in this situation, this is basically bracket times bracket. You don't need to put the multiplication sign there. So when a bracket multiplies a bracket, it's still the same law you are using, but in a more complicated way. And we will look at this in the next series, Intermediate Algebra in full, so that we don't get too much information. The final scenario we will look at is removing brackets that are inside another bracket. So for instance, if we had, look at this expression on your screen. Most of the bracketed expressions or equations you will encounter, that is multiple brackets inside brackets like this, will be from your own creations from word problems. We'll see more of it when we get to word problems. So how do we solve this kind of situation? You will do the innermost brackets first, then you work your way outwards. So let us try it. So what's the innermost bracket? We have to remove this first. So that will give us 3 into 2x. Now remember what we said, there is a 1 here that will multiply everything in the bracket. So this is 2x minus 4y. That is when minus 1 multiplies 4y to give us minus 4y. Then when minus 1 multiplies plus 6, it gives us minus 6. then we close the bracket. So this bracket is now this bracket. This one has gone off. Then plus 5. Now we have this bracket to remove next. So this 3, we multiply everything in the brackets one by one. So this 3 multiplied by 2x gives us 6x. Then 3 multiplied by minus 4y gives us minus 12y. And then 3 multiplied by minus 6 gives us minus 18. Then we put this plus 5. So if we simplify further, it gives us 6x minus 12y minus 18 plus 5 is minus 13. So that becomes the final answer. Let's take another example of this one. Now look at this one. So we start with the innermost bracket as we said, which is this one here. What is beside it? Plus. As plus is beside it, it means that this is plus 1 as we said. So if plus 1 multiplies everything in the bracket, it still gives us the same thing. So this gives us 5 into 3x minus 2y plus 4z minus 7. So we've taken off one bracket. So we go to the next one, which is this one. What is beside it? Minus. So the minus 1, we multiply everything in the bracket to give us 5 into 3x minus 2y. That's if this multiplies this. Then if this multiplies this, it gives us minus 4z. Then if this multiplies this, it gives us plus 7. So we have one more bracket left. So 5 multiplies everything one by one. So 5 times 3x is 15x. 5 times minus 2y is minus 10y. 5 times minus 4z is minus 20z. And then 5 times plus 7 is plus 35. And this becomes the final answer. Let's take a few more examples just to make it stick better. Now look at this example, this one. So we use the distributive law again. This will multiply each of them. And then this will multiply each of them just like that. So that gives us 2 times a squared, 2a squared, plus 2 times 3ab, 6ab, then 2 times minus 4, minus 8. Now on this other side, minus 3 times a. Remember the operator, please. Minus 3 times a is minus 3a. Minus 3 times minus 2b is plus 6b. And then minus 3 times plus 5 is minus 15. If we now collect like terms, it gives us 2a squared plus 6ab minus 3a plus 6b minus 8 minus 15. So that gives us 2a squared plus 6ab minus 3a plus 6b minus 8 minus 15 is minus 23. So this becomes the final answer. Let's take one more example before we take our try exercises. Don't be afraid of this question. To approach it, we just identify each bracket unit as this, and this. We are going to expand them one by one, each of the units, and in each unit we start from the innermost brackets. So for this one, we expand this part first. So this gives us 3 into a squared plus 2ab minus 8. Then for this part, we expand just this part. So that gives us minus 4 into a minus 2a plus 6b. Plus, then we expand this fully. 5a squared minus 15a plus 10 minus 2 into a plus 3a minus 6b. That is expanding just this part here. So that gives us, we expand this fully now. 3a squared plus 6ab minus 24 minus 4a plus 8a minus 24b plus 5a squared minus 15a plus 10 minus 2a minus 6a plus 12b. We have expanded this part fully. So that's all the brackets gone. And this is the end of the question anyway, but I'm going to simplify it to get to the simplest form. When we simplify further, this is what we get. Here are the try exercises in levels to solidify your skills. As usual, we will release the solutions to the try exercises, but try them first. When you try the first level, if you feel confident, you can go to the next one and the next one and the next one. Check our website mathinfo.com for so many more exercises like this to be sure you've mastered everything you need to know. Check the description of this video for the guide to the levels and what the levels are all about. The color codes also will give you an idea of what the levels are all about. The next lesson will be on algebraic fractions, so keep an eye on the channel for that. So this is a wrap on today's lesson, which is removing brackets. Keep studying, and as you do, remember, in mathematics, it's all connected.